Have you ever wondered how data travels from one device to another in a network? Well, the secret lies in the OSI Reference Model, a fundamental key to understanding the complex world of network communications. Stay tuned to uncover the magic behind the network communication. The OSI model, also known as the Open Systems Interconnection Model, is the backbone of network communications. This framework, a brainchild of the International Standards Organization, is a 7-layered structure that standardizes various network protocols into different layers. Each layer has a designated function, with the upper layers dealing with software and the lower layers handling hardware. At its core, the OSI model simplifies the complex web of network communications, making it easier for different systems to interact seamlessly. It's like a universal translator for network devices, ensuring that no matter what language your hardware or software speaks, it can be understood by others. From the physical layer that deals with raw binary data to the application layer where network applications reside, every layer plays a pivotal role. It's a fascinating journey from ones and zeros to user-friendly applications. So, brace yourself for an in-depth exploration of this networking marvel. Now, let's dive deeper into each of these layers. Starting from the bottom, the first layer is the physical layer. This foundation layer is crucial in the world of data communication. It's the layer responsible for transmitting raw bitstream over the physical medium. Think of it as the highway for your data, allowing those binary or 1S and 0S to travel from one system to another. The physical layer doesn't concern itself with the meaning of these bits. It's all about getting them from point A to point B. Here, we're dealing with the tangible aspects of our network, the physical connectivity. This includes everything from the cables connecting your devices to the hubs that help direct traffic. Whether it's copper wires, fiber optics, or even radio waves, the physical layer is the one ensuring these signals get where they need to go. It defines the electrical and physical specifications for devices. In essence, the physical layer is all about turning 1S and 0S into signals. Moving up, we find ourselves at the data link layer. This layer is akin to a meticulous postman. It ensures that data frames are delivered error-free from one node to another. How does it do that? Glad you asked. The data link layer uses a technique called frame sequencing. It numbers each frame sent. So if a frame goes missing or arrives damaged, the layer knows exactly which one to resend. It's like sending a registered mail. You know when it's delivered, and if it's not, you know which one to send again. Now let's talk about MAC addresses. These are unique identifiers assigned to each device on a network. The data link layer uses these addresses to determine the source and destination of each frame. It's like the postman knowing exactly which house to deliver each letter to. So, you see, at the data link layer, it's all about delivering data frames accurately. It's the layer that adds reliability to our digital communications. Next up is the network layer. This layer is like the transportation system of the internet. It is responsible for routing data packets from one place to another, no matter how far apart they are. How does it do this? By using something called IP addresses. These are unique identifiers given to each device connected to the network. You can think of the network layer as the GPS of the internet. It knows the best routes to reach a destination, and it ensures that the data packets are sent in the right direction. But it's not just about getting from point A to point B. The network layer also manages traffic congestion, making sure data flows smoothly without overwhelming the network. This layer is crucial in making global communication possible. Without the network layer, sending an email to your friend in another country or streaming your favorite show would be practically impossible. So, remember, the network layer is the postman of the network, deciding where data packets go. As we move higher, we encounter the transport, session, presentation, and application layers. Now let's dive into the fourth layer, the transport layer. This layer is like the diligent postman of our digital world. Not only does it ensure that our data packets reach their destination, but it also ensures they arrive intact. The transport layer is responsible for end-to-end communication, error detection, and correction. It makes sure that all the data packets are delivered in the right order without any missing or damaged packets. So next time your video streams flawlessly, remember to thank the transport layer. Moving up, we meet the session layer. This layer is like the conductor of an orchestra, ensuring that all the instruments play in harmony. It establishes, manages, and terminates connections between applications at each end. Whether you're video conferencing with a colleague or playing an online game, it is the session layer that keeps the communication flowing smoothly. Next, we have the presentation layer. This layer is the translator and protector of our data. It provides a common language for the data so that the receiving system can understand it. And it's not just about compatibility, it's also about security. The presentation layer is responsible for encrypting the data to keep it safe during transmission. So when you send a sensitive email, it's the presentation layer that keeps your secrets safe. Finally, we reach the topmost layer, the application layer. This layer is our interface with the network. It provides networking services to end-user applications. When you send an email, browse a website, or share a file, it's the application layer that makes all this possible. It's like the friendly shopkeeper who makes sure you find exactly what you're looking for. From transport to application, these layers ensure data is delivered correctly and is understood by the receiving application. So the next time you click send or download, remember there's a lot happening behind the scenes. Each layer of the OSI model plays a crucial role in making our digital world run smoothly. Let's recap what we've learned about the OSI model. This 7-layered model is the backbone of network communications, and each layer has a distinct role to play. Starting from the bottom, the physical layer is where the rubber meets the road. It's all about transmitting raw bit stream over the physical medium. This layer ensures that the electrical, mechanical, and procedural interfaces are in place for data transmission. Moving up, we have the data link layer. This layer is the traffic cop of the OSI model. It provides error-free transmission of frames from one node to another over the physical layer by organizing bits into frames and controlling access to the physical medium. Next is the network layer, the postmaster of our OSI model. It's responsible for routing data from source to destination through internetworks. It takes care of logical addressing and path determination, ensuring your data packets find their way to the right address. The transport layer is the reliable postman, providing end-to-end transport services. It ensures complete data transfer, maintaining the quality and reliability of the communication. Moving into the session layer, think of it as the coordinator. It establishes, manages, and terminates connections between applications at each end. It's all about the dialogue control. The presentation layer, our translator, ensures the data is in a usable format. It deals with data compression, encryption, and translation services, making sure the application layer receives data it can understand. Finally, the application layer is the front end of the OSI model. It's the interface between the network and the application software, providing network services to the applications. And there you have it, the 7 layers of the OSI model, each playing a vital role in network communications. From the physical transmission to the applications that we use, each layer has a specific function, and understanding each one gives us a better grasp on how networks operate. Remember, understanding the OSI model is key to mastering network communications. And with that, we conclude our exploration of the OSI model. We've demystified the OSI model together, haven't we? The layers, their functions, their interconnections, they're no longer a puzzle. This understanding is crucial not just for passing your CCNA exams, but for your career in networking or IT. It's the language of the digital world, the blueprint of how data travels from one point to another, and now you speak it fluently. So, go ahead, apply this knowledge. Let it guide you in your studies, in your work, in your pursuit of mastery. Let it open doors to new opportunities. Let it make you a better IT professional. Thank you for joining Tech Spectrum Pro today. Don't forget to like, share, and subscribe for more technical insights.